Hi mates! Today we are talking about 3D printers, maybe the most valuable tool in my workshop. This is my trusty Longer LK4 Pro printer, which I have for a couple of years, and a week ago I noticed one of the belts was stretched and needs changing, so I decided it's due time for an upgrade. As I was well prepared as usually, I expected this to be pretty fast work. Man, I was so wrong. But first, what you'll see in this episode. I drill some holes, make an unfortunate miscalculation, and manage to print a cat. So today I give you the story how I built the most expensive LK4 Pro printer in the cheapest way possible. So all of these parts now have to go on the printer. As my printer is quite close to reality, I was hoping I would find most of the parts for download. Well, it wasn't the case. Whatever I found was off by some millimeters and I had to redraw all of them myself. The rest was sourced from Aliexpress and its upgrade for Creality CR10 or Ender printers. I've been holding on to these parts for quite some time as my printer is always in use and I never found the time to upgrade. As time came to sell it, I decided now it's the moment to do it. So first of all, I will be putting linear rails on all the axes. Had this big metal gear extruder for quite some time, so I will be putting it on direct drive as well. As I had it from before, I didn't put it in the calculation, but yet again I bought it on Aliexpress, so it was quite cheap. A smaller stepper motor is also in order for the extruder to keep it white. We'll throw in the mix this cork damper that I had from before, why not? These are some of the printed parts I designed to mount the linear box. All printed in PETG. This block is a little different. It goes on the left side of the gantry. There the linear rails will be mounted on the inside of the vertical posts. This would be another Aliexpress part. It's the mount for the Y-axis under the bed. I bought a complete X-axis mounting kit which has multiple configurations. You can mount it either on rollers or linear rails. It also comes with a bracket for direct drive extruder and a touch sensor. It has a standard interface for a J-head, but of course you can mount this one as well with the proper adapter. This E3D clone I had from before, and this was my preferable hot end that I used for the past 1 year. Next I ordered these brackets to mount the guide rails, but I forgot they are meant for 9mm ones and I am using 12mm rails. It's not a direct fit, but I will make it work. If you're going for 12mm rails, better order 6 separate brackets instead of 3 double ones like I did. I also ordered these Creality belt tensioners to change my 3D printed ones. I was pretty happy with my printed ones, but for the price of mere €2 I decided to try some plastic injected molded ones. So all these Aliexpress bought parts except the extruder and the hot end that I already had amounted to a little less than €200. It's a hefty sum, I know, and these were the cheapest parts possible I ever found on Aliexpress. A complete bill of materials and the printed parts you will find in the link below in the description. The only thing left now is to put everything on the printer and see how it worked. I decided to start first with the Y-axis. It was supposed to be the easiest mod and it also would give me presumably the most stability I expected from these upgrades. The first thing to do was to remove the old bed. This would give me access to the whole assembly so I can proceed further with the upgrade. As I have forgotten how I did it the last time, I started by removing the tensioner, which is totally unneeded. It's a simple job of just disconnecting the heat bed and removing all the retention screws from the bottom and it just falls down. Collect all the small parts as maybe you would need them later and also be careful not to scratch your bed. Next step would be to cut the zip ties holding the belt and remove the carriage for the Y-axis. Nothing complicated here, and with this carriage out of the way I can get to some real work for upgrading my printer. So let's assemble some rails now. Be extra careful with the orange end stops on the rails as they prevent the block from falling out from the rail. Not that it's very complicated to put it back on the rail, but in the process you could lose some of the ball bearings inside. They are very small and quite easy to lose. On the upside, the rails come with some extra bearing balls, so you can replace them. So the assembly was quite easy here. The only thing to do is mount these bed support brackets to the rail block. All the needed mounting hardware came with the kit, so I was pretty happy about it. Making a quick test fit before I proceed, I realized I make a big miscalculation. This kit is meant for Creality printers and they have quite different undercarriage construction. As the rail block is a little wider than the extrusion profiles, it cannot pass over the underlying support here. And on this terrible disappointment, I decided to assemble the carriage as it was and proceed with something different. With so much time lost, I decided to step up a little bit the things and start with upgrading the gantry axis. It's one of the most complicated parts in this upgrade. You have to remove everything from the gantry axis in order to start the actual upgrade. First off, we need to free the tool head and remove the belt holding it in place. This belt was actually the stretch one and I started the whole process because of it. Next task was to remove the cooling fans from the tool head. This took me quite a while, but everything would remain attached to the printer as I would be using this hot end going forward. After so long, I'm still removing the cooling fans to clear the hot end. With this out of the way, I finally have access to the adapter bracket holding my E3D clone hot end. So let's get it out from our way and gain clear access to the roller cage for the tool head. Even this is not an original part. It came with the dual blower fan upgrade kit provided by Longer themselves. Going forward with my upgrade, I will not be using this part anymore. The only thing that I would need from here is the second part of the adapter for the hot end. As everything was disassembled either way, I decided it's an opportune moment to change my nozzle on the toolhead. First we start with removing the cooling shroud. It's machined out from aluminum and it's pretty tight fit, so it's not an easy task to remove it. Imagine what is putting it back together. As both my nozzle and heat break needed replacement, the hot end needed to be disassembled completely. As this is cheap clone of the tool head, I am also using cheap parts for replacement. The heat block itself can remain attached as I will continue to using it. With all this out of the way, we can proceed with disassembling the gantry. Let's start with this particular roller. On this side of the assembly you can see Longer are not using a back plate. This was something I had to design as we needed one going forward. Now is the good time to remove all the cables from our way. Another non-original part, this is a dual gear extruder which is quite cheap and served me well, but I will not be using it going forward. As I am moving to a direct drive, this motor I would not use anymore. So I don't need anymore this backplate with extruder mount, but I was too lazy to print another part, so I will keep it going forward. Final step is to remove all the ball bearing rollers and clear up the gantry assembly. The ultimate goal was to reuse as much original parts as possible, so both these plates on left and right of the gantry I will keep. With all these parts out of the way, it's time to deal with something fun. The 300mm rails will be for the Z-axis. One of them will go on the outside and the other on the inside of the vertical structure. And again, be careful with the end stops so your rail blocks don't fall off. Let's start by assembling the mounting hardware with the rails. I'm using 4 bolts and T-nuts per rail. Nothing special here, but it's not that easy while keeping the rail block not from falling over. In my opinion, the Z-axis is the least important from the 3 to upgrade to rails. It would have been perfectly fine if I left it on rollers, but as I wanted a complete overhaul of the printer, I said to myself, why not? With the tedious task of installing all the mounting hardware, we can proceed by placing the rail on the side of the aluminum extrusion profile here. Tighten one of the center bolts just enough to hold the rail in place. I strongly suggest you use these alignment blocks as they will make your life much easier. By using those I managed to perfectly align both my vertical rails, so didn't have to adjust anything later on. Tighten all the bolts one by one, and if you did everything properly, you have a perfectly aligned rail at your hands. Now let's move to assembling the printed parts. The original mounting hardware on this plate on the gantry will not do the trick. Either you need to find a longer bolt or you use 2 shorter ones to mount the standoff. Don't tighten it all the way as it can be adjusted later when you assemble everything together. Assemble the plate with the original 2 bolts. This block will be the mounting point for your right side of the gantry. You assemble it with 16mm M3 screws. While I tighten them in star pattern, I am hoping everything was designed properly and I will have a good fit. Tighten everything properly and let's move to the other side. We repeat the same process and remember the alignment box make your life easy. Hopefully these helpful tools did their trick and I have perfectly aligned rail on this side as well. Better option is to mount this rail on the outside, but then I had to redesign a lot of parts as the X motor has to move a little on the left and this is too much change to the whole construction. Both rails on the outside will provide you with a much more stable gantry as the mounting point will be outside of the vertical construction. But of course, as I was too lazy to design all the parts, it was much easier to go only with this block on the inside and call it a day. Only one part is needed to mount everything using the original mounting points of the gantry. With this block tightened in place, we can proceed with mounting the gantry itself. This block was designed to use M5 by 20mm bolts. Hopefully my design is good and I managed to get all the dimensions right. I don't have a printer now and if I have to change something it would be quite unfortunate. Let's tighten this side of the gantry and see how it goes. Let's put one bolt on the other side and check the alignment. Looks good. As things seem quite favorable, we can move to the other side and proceed with mounting the backplate. The original design of the Longer printer doesn't feature a backplate here, so I had to design one of my own. This backplate will hopefully keep my vertical rail block in place and properly aligned. All this M5 mounting hardware I'm using are not the original as I needed longer ones because of the backplate. Using two short bolts here on the standoff work properly as well. Using 3-point mounted backplate hopefully keeps my right side properly aligned. After adjusting the left block and tightening, it would seem I have a good vertical alignment. Let's finish off this side by mounting two spacers to keep both plates properly aligned. As I didn't introduce any change on the structure on this side, I'm using the original mounting hardware. Let's tighten everything down and if I did things properly, I would have a very easy moving vertical axis. It would seem this is the case. The lead screw alignment block had to go as it is not proper fit for the current installation. Converting to vertical rails, you can clearly see move the gantry sideways by a couple of millimeters. The original mount bracket is not adjustable, so I had to figure out a way how to move the motor sideways. The easiest way to do so was widening the holes on the original bracket so it becomes adjustable. After drilling them for some time, it would seem I have a proper alignment now. Let's tighten the motor in its new place and finish the lead screw assembly. It would seem everything is properly aligned now. Moving the gantry up and down is quite effortless and it's much smoother than before when using crawlers. At the end, converting the vertical axis to rails proved to be quite an upgrade. Next off, it was time to tackle the X-axis. As I'm using mostly store-bought parts here, it was supposed to be quite an easy task. As I mentioned before, I bought the wrong brackets and these are for 9mm rails while I am using 12. I decided to cut them in half so I ultimately get 6 mounting points on my rail. As the battery operated Dremel tool was too weak, I switched to my regular one. After quite a long time and 4 armored cutting discs gone, I managed to finish this tedious task. Now let's prepare the brackets by attaching the mounting hardware and move along. Here comes the interesting part, assembling the toolhead. This kit is quite universal and it can work both with linear rails and rollers. First I have to attach the mount bracket to the rail block. The backplate is designed for the original J-head, so I have to attach the adapter for my upgrade hot end. You can print one such adapter, but I bought this on Aliexpress as it is metal. The direct drive motor mount is very adjustable. Main issue here would be that I'm using aftermarket hot end which sits further out from the original one. Let's mount it temporarily on the backplate so I can measure the position of the extruder. This is another clone part I bought on Aliexpress. It's big metal gear extruder and it's quite powerful. I didn't need it for my Bolden setup, but here it would be definitely welcome. Unfortunately, because of the outwards position of the hot end, I can use only 2 screws here to mount the bracket. Fair enough, it should do it. Let's proceed by mounting the extruder. The extruder had a design flaw. It needed to be shimed on the back. If you attach it to a thin bracket as I am doing currently, the motor shaft would block the gears fence and the extruder wouldn't work. I also had to skip the damper here as the bolts were not long enough to fit both damper, motor and extruder and bracket. Let's tighten it all the way and see if it moves freely. My guess is I assembled it properly. It looks to be working perfectly fine. With this done, I can proceed and assemble the hot end. Part for another cheap spare part. B-metal heat brake. Next we need to make the actual interface between the hot end and the extruder. Insert the tube all the way in the hot end, measure it roughly and cut a longer piece. After several attempts I managed to get it at proper length. Do not be like that guy, that he cuts it 3 times and it is always short. Visual inspection indicates that I possibly did the things properly. Time to verify with actual piece of filament. It fits quite easily through the tool head. Another great success. I managed to assemble something I bought on a store and it was supposed to work in the first place. With this fun task completed, it looks like we are ready to press on. It was high time we mounted the X-rail and see if everything fits together properly. Start by assembling the mounting brackets, all 6 of them, which were 3. This is why you should properly read the description when sourcing parts for your projects. These brackets are perfectly functional but extremely ugly. Not that they can be seen, but I will always know that they are there. And here you see another shortcoming of the design with the rail on the inside. You don't have much space on the extrusion profile, so you have to mount these brackets quite close together. It's not a big issue though, as the 12mm rail is quite stiff and stable. This is not something to worry about. Let's tighten all the screws and be done with it. This being a single rail on the x-axis, we shouldn't care so much about alignment. The only thing to worry about is the rail block to clear all the other parts of the printer. It looks this also was completed successfully, as the rail block moves end to end without any issues. And here another obstacle which I knew from the start but forgot to prepare for. Toolhead backplate doesn't have a roller anymore here, so it cannot hit the end stop. I had this orange piece from a failed print which fit perfectly and did the job. This was made as temporary solution, but I'm sure it will remain in place till the end of the life of this part. The only thing left is to assemble the toolhead with the mounting bracket. End stop seems to be working well, also the toolhead clears the rest of the printer. I think this is a success. Time to finish the toolhead and we will get an operational printer. First off, we need to reassemble the heat block. Easy exercise, just follow the standard procedure and assemble the hot end of your choice. With the nozzle in place, we can tighten it a little and proceed to mounting the hot end on the plate. I assembled the adapter here and preheated the nozzle to 250 degrees so I can tighten properly the nozzle before final assembly of the toolhead. With this properly done, leave it to cool down before proceeding with next step. Remember the machine made shroud? Now it's the time to put it back on. It is really a tight fit and complicated task to slide it back in. For this I would need to use some proper tools. Like this retro screwdriver that will help me slide it back into place. With this completed, let's put the retention screws in their proper place. Hot end can be mounted now on its respectful place back on the toolhead. Reassemble the adapter bracket. Put all the fans back on place and we are done. This toolhead is quite bulky and actually is quite heavy as well, even when using the small extruder motor. I think buying this metal extruder was not the best decision I ever made. Most of the added weight actually comes from the rail itself. It's quite heavy and this resulted in a very heavy gantry. As I have everything opened at the moment, it was an opportune moment to mount the touch sensor. The kit comes with a mounting bracket, so this was a quick task. Let's try now to mount this fancy tensioner. It is designed for render printers, so naturally it didn't fit out of the box to mine. I ended up cutting quite a lot from it to try to make it work. At the end, even when I managed it to fit properly, I could use only one retention screw to mount it. On this terrible disappointment, I decided to stop wasting any more time and put back the 3D printed tensioner. It served me well for years, so it can definitely do some more. This was one of the first upgrades the printer printed for itself and I'm pretty happy with it. Next we have to deal with the extruder motor. As I'm using an aftermarket one, Bear in mind that not all of them have the same pinout, and this is exactly the case. The longer motor has quite different pinout. If you connect it wrong, you'll definitely fry your motherboard. As the position of the motor changed, I had to make the cable longer as well. I will not get into details how exactly I rerouted the cable to work with my new motor, as I don't want to be responsible if you fry your motherboard. There are a lot of videos online how to do this properly, so follow them. Hopefully I did everything properly, and now the extruder will work as it is supposed to. Let's load it up with some test filament and try to move it with the printer controls. Looks like another small success to me. I spent a good half an hour trying to mount the belt at this stage, and I figured out I cannot do it. I had to add this small bracket as the tool head is offset and the belt didn't fit well. Next we have to deal with the belt itself. Start by routing it through the tensioner and then on the other side through the motor. Measure and prepare the first loop that will go on the back plate. Now I simply have to slide it on the bracket I already installed. Moving to the other side, I just repeat the procedure. Of course you have to measure the belt properly so it stays a little loosened up when the belt tensioner is not engaged. The only thing left is to check if the belt fits inside the gantry profile properly, which it does. Time to deal with some cable management. Start by zip tying them at the end position of the tool head to figure out how much length you need. I used before cable chain here, but after the upgrade I didn't find any good mounting points to introduce it again, so I had to opt in for this original cable guide. It hurts my eyes to look at it and not have the printer vision complete, but this was the easiest thing I could do without having to print some more parts. After I check it fits properly in all the end positions of the printer, I can proceed and mount it securely on the other end. I would say this would be it. For the Z-axis I would reuse the chain I had from before. It takes some time to reassemble, but it's quite satisfying task to see how everything fits together at the end properly. Let's make a final test and see for the chain to fit the whole travel of the Z-axis properly. And again, here we are. We have to deal with the Y-axis. As I didn't have working printer at the time, but I needed more parts to make everything fit properly, I decided to fabricate them by some other means. I had some leftover piece of metal bond, which is material very used to work with, and I would make from this some shimming to make the proper alignment of both rails. It's quite easy to cut and still remains properly flat, so it would be great for the purpose I'm using it here. To save a lot of time here, I decided to use double sticky tape and placed it on the spot it would remain further on. Next I simply had to drill the corresponding mounting holes with my hand drill. This was fast and based on my calculations should work perfectly well. So we finally reached the point to mount the rails on the aluminum extrusion profile. Start off by measuring where to place them exactly correlative to the belt tensioner. Again, help yourself with the alignment box, they will save you tons of trouble. With one side done, proceed in the same fashion with the other. With this being all machined parts and me using those alignment box, my hope was that I will have perfect alignment from the start for both rails. With both rails in place, I can proceed with the next step and mount the bed carriage. With this kit intended for ender printers, of course it doesn't fit my part precisely. I will have to make it fit, but I knew from ahead that I will have this issue, so I am prepared and have a solid plan how to deal with it. And this would be me drilling new holes on the carriage. It's lucky here that it has good position that I can drill those holes and make it fit. This was quite fast task to complete and hopefully I did it right. I was very careful and started with small drill bits moving all the way up to M5. I quickly reached the moment of truth. Will it fit now? You can very well see on this footage that the original holes on one side are bigger to provide you little adjustment. Mounting the plate on the rails revealed that I made these 4 holes perfectly. This is the first time in my life ever to drill 4 holes and they fit all of them properly. When tightened them down all the way, I found some resistance in the rails. At this point I decided to open up 2 of my holes to 6mm for better alignment. Well, this doesn't help at all. It was a small improvement, but at the end I figured out this was because of the plate being bent and not because of alignment issues. I proceeded to oil the rails and it started working very smooth. When properly oiled, I found out this to be extremely smooth and much better than when it was with rollers. So it was time to clean the leftover oil and proceed onwards. Next step logically would be to assemble the belt. Tracing back all the steps when I disassembled it, I had just to pull it through the profile, assemble the belt tensioner, slide it in and ultimately put it through this hole on the undercarriage and put some zip ties and I'm done. Y-axis is finally assembled, running smoothly and ready to be installed on the printer. But on the other hand, as it sits 5mm higher, this introduced another issue. This nice storage system that I have under the bed of the printer will not fit anymore as the middle rail sits higher. Thus, I had to make a new spacer for a metal bond and try to make it work this way. I didn't want to have to print all of this again just for the 5mm difference. With this completed, I had to mount the Y rail back on its place. The original screws fit perfectly, so I proceeded to tighten them. The holes provide you with some space for adjustment, so you have to properly align this rail and try to make it as parallel to the understructure as possible. Next, I tightened my modified storage containers and it proved to be working quite good. As you can see, all the storage is back on their place, operating properly. These drawers will continue to serve me well. Yet another great success. I would say about now it was high time to mount the bed back to its place. I opted for these silicone standoffs instead of the springs I had before. As ultimately I will have bed leveling sensor, this was a logical upgrade. Position the bed properly, turn back the retention nuts, tighten them, bob's your uncle and off you go. With the bag back in place, it was time to put some blink on it. I finally decided to finish my bed cable chain. All these parts were printed long ago, but I never had the time to actually install them. At the end, I'm pretty amazed this actually worked and everything fit properly. With this chain in place, the printer started looking much more professional. Don't watch the ugly brackets I have up on the gantry. I really hate them, but it's good thing that I don't watch the printer from the back so often, so I'll rarely see them. With the last chain link safely secured with some double-sided tape and screws, the only thing left was to finish the cable shroud. Chain works properly, it seems I'm done here. Yet another success, I am on a roll today. The outcome seems close to perfection. I wonder if it will work. And what better way to test it than print some more upgrades? Come on, look at it go! After the unfortunate weight gain in the gantry, I had to install another upgrade. I have to admit it was totally expected and I had some preparation for it. These parts were actually printed in the half upgraded printer, so he is building again himself. As I'm using original longer motor which was left from the extruder, I just had to make a cable and connect it to the second Z motor port. Worked in the correct direction, so I proceeded to mounting it with this adjustable motor mount I found on internet. Next I had to remove the backplate and exchange it for the one that I made recently, which will allow me to put a second Z-axis lead screw. Again, I tried to find something ready on the internet, but as this is a little different than the Ender printers, I had to draw it from scratch. I was quite lucky that everything fit together from the first attempt, so I didn't have to reprint any parts. The rest is straightforward. You assemble the lead screw, adjust it like 1000 times, and then proceed to final tightening and so on. Stepper motor had to be pushed a little on the side, but altogether it was a good fit. Again now multiple adjustments to put the lead screw in the coupler and tighten it properly. It's quite fiddly bit to assemble the second axis as they are not interconnected, but it was definitely needed in my setup. And now let's try to see how it moves throughout the printer controls. It looks quite good to me. So now I move it up and down a bit so I can finally adjust the lead screw assembly. With this in place, I proceeded to mount the second Z lead screw stabilizer. This controversial part in a 3D printer, but as I use these highly adjustable ones, I actually managed to do them properly, so they are helping me a lot. Let's move the gantry up and finish assembling the second stabilizer. After it, we test if everything fits and works properly. Seems legit to me. I think I managed to make it good. We will see when I start printing. I reused the extruder motor, so I actually had to buy very little parts for it. This was pretty easy mod. As the wire rail was preventing me to properly adjust the end stop, I designed and printed this shroud. It's a direct replacement of the original part and it's intended to go a little over the rail so I can adjust the bed to be centered. Using all the original hardware, I only need to assemble it and put it back in place, connect it to the cable and adjust it properly. Again, this was good fit and it was fast completed. And on this footage here you can see that the vertical inside rail is in the way of my printer bed. I spent a lot of time filing it down as I was too lazy to remove it and cut it, but still if you don't position your magnetic bed properly it will be in the way. Something to keep an eye out for. As I am using an aftermarket hot end which is quite different, the touch sensor bracket didn't fit as well good. This is why I printed these spacers. Another Creality tool I found on Thingiverse which was not direct fit for my printer, so I had to make it longer. With these vertical alignment markers I am able to easily adjust my Z-axis position from both sides. The last 10 mm of travel of the gantry you have to adjust by hand until it lays down properly on both markers. This tool helps you on the long run to adjust quickly your gantry height, and if your touch sensor works properly, you are set to print very fast. As I was quite out of time and eager to start printing, I didn't connect the touch sensor, so I had to level it the old-fashioned way. With this out of the way, the printer is ready for action awaiting my command. Even the Y offset is centered properly now. As the printer would change owner very soon, I started immediately printing my next big project. This print is about 36 hours long. As I will not have a printer with such big bed anytime soon, I had to squeeze in like 200 hours of print time very fast. Nicely done. Right about now it would seem the correct time to print another Kelly Cat. And with 150 mm per second, which is about the theoretical speed for this hot end. 20 minutes less, not that bad at all. So now let's compare the three cats with the first one I printed at 70 mm before the upgrade. It's not ideal, but it's quite possible. Next one was printed at the same speed right after upgrade before I installed the second Z-axis. It's not that bad, keeping in mind that I didn't do any calibration of the printer. So after I installed the second Z-axis, I went for the 150 mm per second and this is what it came. Again, not much calibration on the printer done whatsoever. So I had to squeeze in some projects fast. These are parts for my new magnetic paddle shifter. They are not the best quality, but without any calibration done on the printer, it's okay. All of those were printed at 100 mm per second right after I finished the complete upgrade without any proper calibration done. And now let's take a closer look to the big parts I printed. This one took 36 hours and I needed 2 of those. All of them were printed in 100 mm per second. Of course they have issues, but I don't care. These being big parts, they are totally functional and I didn't have the time to spend and calibrate properly the printer. So it was an okay outcome. At the end it was a complicated task, but it was totally worth it. I learned tons of stuff which will help me in my future projects. In the process I upgraded my obsolete printer to be much more in line with the contemporary ones, and he is totally ready to accept now a Klipper board and reach even higher speeds. As I am able to print such big parts without any calibration, and right after I upgraded, it tells me I did something right. For the €200 I paid, I brought my old printer to modern standards, which is a win in my book. It's not only faster, but everything is stiff and stable now, it requires less maintenance and it's also much more quiet. The best part is you don't have to do all these upgrades. You can select which axis to upgrade and upgrade the rest later or leave them as is. What I would recommend is definitely switch to direct drive extruder, maybe not so heavy as mine, and also upgrade to rails on the y-axis is one of the best of the three upgrades, as it provides much more stable bed which requires less calibration. I would be happy to leave the rest with rollers, but yet again now it's much better. The only downside is the gantry becomes very heavy and you have to upgrade to dual Z motor, which either way was in my plans. And now I am able to print much faster my next project. I really wonder what it could be.